Perimeter and area of similar figures. Here we go. Standard 8G4 in your notes. We're going to talk about it. You can see it's already in front of you, but let me take it little bit by little here on this screen. We're talking about two figures are similar. Again, here we're talking about that phrase similar. Remember, we talked about it before where they're going to use that sign, little squiggly line. These two figures, when we're talking about it, they're ratios. Remember that word ratio means the fact that we're comparing two numbers by division, aka a fraction. So if you want to make that note off to the side that we're making fractions today, you can do that. If you don't, that's fine. But we're going to make this ratio or fraction comparing the perimeters and their corresponding sides. Actually, we're going to make proportions. It looks like this when we're looking at a shape or a figure. Sounds a little bit or seems a little bit unnerving, but all we're talking about is, again, if we compare the two, if you pick side AB and compare it to side QR, again, looking right here, that ratio or that fraction will be the same as their ratio or the fraction when you compare both perimeters. It's a lot of letters, so it doesn't matter what side you pick. Again, so if you're picking a different side, you're going over here and thinking QZ, or actually I should say SQ. That compares over here to your CA. Again, any side will work. That's what that whole thing right here, that's all this is saying. Any side you pick, don't use them all. Pick one side and its corresponding side in the other figure. That ratio, that fraction will come out to be the same as their perimeters. Let's practice. Notice again, it says find the ratio. So we're going to talk about a fraction of the perimeters, and it already tells you that they are similar trapezoids. Careful. Read instructions very carefully. They say find the ratio of figure 1 to figure 2. You don't need to write it on in, but I'm going to, and in fact for your notes, I want you to write it on in. Please put down that our ratio is going to compare figure 1 to figure 2. Meaning, find a side in figure 1 we know, 21, and compare that to a side we know in figure 2. Not just any side, the corresponding side, and that's 15. Now, I'm going to have you do something silly there. I want you to simplify that, and many times we're going to say, all right, well, that is the same as 1 and 6/15, which is 1 and 2/5. Everybody go ahead and show me that work, and here's what I want you to do. I want you to take and I want you to cross that off. Literally cross it off. Last time I tried this, I wasn't able to erase this on my program, which is fine. I want you to cross that off because remember, we said the ratio is a fraction. That compares two numbers. A mixed number has 3. That will not work. So today, as strange as it sounds, we're going to take this fraction and we're just going to reduce it. Since I can take a 3 out of both of them, that is what I'll do. I'll divide the top by 3 and I'll get 7. And I'll divide the bottom by 3 and get 5. Even though that's an improper fraction, that there is your final answer. That is the ratio. It is a fraction. It involves two numbers. Now, we're going to look at a different slide in a moment, but knowing that ratio, if I told you the perimeter was 70 for this first trapezoid, doing just a little bit of math and knowing nothing else about trapezoid 2, you could actually tell me the perimeter of it is 50. Neat. Moving on. We're going to talk about area of similar figures. Same thing, we're talking about similar figures, and we're going to use this word again, ratio. So we're going to write a fraction to their corresponding sides, but here's the important thing, everybody. Do something with that word area. Remind yourself that area always has units squared. So if you're talking feet, it's feet squared. If you're talking meters, it's meter squares. Thus, their ratio will also be squared. Here's what it looks like with the figure. Again, you can see it in front of you. Boom, there it all is, really, really fast. Let's take it step by step. Picking a side in that first triangle. Oh, jeepers. There should be a triangle symbol down here. Please insert that. Triangle ABC, triangle DEF. That was lost in the program. But moving on. You've got side AB, and that corresponds to side DE in the second one. Seeing that ratio, all we're going to do is we are going to square whatever that result is, thus the 2 on it. You can pick any corresponding side, thus there are 2 more examples. As long as you know one side and the corresponding side in another figure, today we're going to square that fraction or that ratio. Let's talk about an example. Again, a ratio, 2 numbers. If we were in class, I'd make you say 2. Feel free to shout out 2 right now if you'd like. Did you do it? Oh, I hope you did. If not, we'll still move on either way. Careful, read instructions. Which figure do they want first? Figure 1, figure 2, the red one, the blue one, the left, the right. Be very careful. It says figure 1 to figure 2. You do not need to write that in. It will not make you, except for here in your notes, please do it. But on your assignment, not needed, but very, very helpful. So knowing that we're going figure 1, again, pick a side in figure 1 that you have a corresponding side to in figure 2. And now because we're talking about their area, when we're doing area here, remember, we talk about area squared, which means we need to take and square this ratio. So we're going to take and square it. Now, my tip for you is not to go right away and tell me that it is 81 over 36. You are correct, but then you need to simplify that down to something. What I would recommend, instead of taking that path, I would say, can you simplify, or rather, can you reduce 9/6? Don't tell me it's 1.5. A ratio is 2 numbers. Again, if we were there, I'd make you say 2. Go ahead and say 2. Did you say it that time? Either way, moving on. Simplifying 9/6. That comes down to 3 over 2. Now square that. That's a little smaller number, and we get 9/4. Well, that's exactly what this comes out to be. But if you reduce it first, then there's less work, or at least in my opinion, less work to do. Now that you know the ratio of the areas is 9:4, we can do some fun math. But in this case, this problem, all they wanted was the ratio, so you're done. Again, 9/4, improper, but it's a ratio comparing 2 numbers. Many times when we're looking at it, here we go. This is where we're going to use it. We know stuff about this courtyard, or not court, excuse me, a volleyball court, and that we're told that it is similar to a swimming pool. Both rectangles, so that means it's talking about corresponding sides. We can do things with area and perimeter. Down here, you can see we're told some information about the court. We'll refer to that. And now a lot of times when we see this and we say, see the area, you're going to think, all right, area is length times width, but not today. Don't do that. Let's see if my program erases it. Nope, it doesn't. It erases on my screen, but not on yours. Do not do length times width. Today we're talking about using ratios. So again, here's what we're going to do. I'm going to come over here, and I'm going to do the ratio of the court to the pool. Yes, you're allowed to put C over the letter P if you'd like. And I'm going to do the ratio first of corresponding sides, which means I'm going to do 10 over its corresponding side of 22. Now, before I do anything else, I'm going to simplify that fraction. I'm going to simplify that ratio, which gives me 5/11. Now, knowing the ratio, let's find the perimeter. Let's find the area. Starting with perimeter, and I'm going to label it so I know what I'm doing. I'm going to put the letter perimeter right here. So using this ratio here, we'll write that on in the perimeter. Well, the ratio of perimeter is just that ratio, 5/11. Again, doing court to pool, so knowing more about the court, coming back to the court and seeing its perimeter is 60, I'm going to put that on top. And since I don't know the perimeter of the pool, I'm going to put the letter P down here. You can use any variable, but I'm going to use the letter P for pool. Actually, more so P for perimeter. Just a little reminder for myself. And now we're going to come here and we're going to do the cross product, where you're just going to take and multiply them again. Show me this word. 5P. And then the other cross product, going and multiplying these guys. 11 times 60. Yeah, you can do that mental math if you want. Yeah, go ahead. Use a calculator. It's perfectly fine. Don't need to do that math mentally. And then here we are. Lovely one-step equation. Solve for that letter P. perimeter equals. Mental math, sure, great. Just make sure it's correct. Want to use a calculator? Great, do that. And now the perimeter has a label of yards. So knowing nothing else about that pool except for one side length, you know the perimeter is 22 yards. Excuse me, 132 yards. I don't know where I got that number. Careful. The instructions said to find both the perimeter and the area. So over here, I've got room. But now remember, when we talk about the area, area's label is squared. Again, if we were together to make you say squared, feel free to say it now. I won't ask if you did. But we need to do that. So please, quickly, before we do anything else, put this in parentheses and square it. Meaning, what's 5 times 5? Not 10, that's 25. 11 squared, if you square the top, square the bottom, again, that's not 22. That's 121. Knowing again that we've gone from the court to the pool, the court on top and the pool on the bottom, I'm going to go back to the court, and I know something about it. I know that down here, you have to find it. They're going to put it somewhere, that the area of the court is 200. And once again, I don't know the area of the pool, so you're able to pick whatever variable you want. I'm going to put the letter A just because I'm solving for area, and that's going to be a little mental clue and a helpful hint, a reminder to me. Cross product 25A, and if you'd like to, yeah, you can do 121 times 200 mentally. Yeah, make sure you get them all right, but please, 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 just use a calculator. And then again from here, divide it on out. Get that 25 on both sides. Show me that work. Divide it on out by 25. And that gives us A equals 968. So your area of the pool, knowing nothing else, is 968. Now again, remember, we talked about it. The label for area is going to be squared. I've run out of room here on my screen, so I'm just sneaking it on in here. But because the label is squared, that again is why up here we had to square that ratio. For us, if you're having any troubles talking about just finding the ratio of perimeters, remember that's just two numbers, do nothing else. And when you're looking here and you're talking about the ratio of the areas, remember area is squared. And away we go. For us, this year in 2018, we're watching this video because of a late start. And I've already told you guys that don't worry, try this book assignment right here. And we will talk about it on Tuesday, and we'll have a review day. If you're watching this for another class or another year, see me before or after school or in Ramrock as well if you have any questions, and I'll let you know about day twos or any other reviews we are doing.